Dear students, I am Khandakar Fazle Rabbi, lecturer, Milestone College, Uttara. Today we discuss about some creative question from chemistry first paper, chapter 3, periodic properties and chemical bonds. Dear students, here is stem 1, X, orthonitrophenol, Y, paranitrophenol. They are given AH4, BH3 and C2D. The atomic number of A, B, C and D are respectively 6, 7, 1 and 8. Question number C, melting point of X. X means orthonitrophenol is lower than the melting point of compound Y. That means paranitrophenol. Analyze. That means melting point of orthonitrophenol is lower than the melting point of paranitrophenol. To discuss about this question number C, we must have to know the basic concept of hydrogen bond. What is hydrogen bond? A chemical bond formed between an electropositive hydrogen atom and a strong electronegative atoms such as oxygen, nitrogen, fluorine is known as a hydrogen bond. The strength of hydrogen bond is less than the strength of ordinary covalent bond. This hydrogen bond is also 5 to 30 kilojoule per mole stronger than van der Waals interaction, but weaker than ionic and covalent bond. Hydrogen bond, this hydrogen bond has the influence on physical properties, but it does not change chemical properties. There are two types of hydrogen bond we get. First one is intermolecular hydrogen bond and second one is intramolecular hydrogen bond. What is intermolecular hydrogen bond? When the hydrogen bond is formed between hydrogen atom of one molecule and an atom of the electronegative element of another molecule is known as intermolecular hydrogen bond. Intermolecular hydrogen bond, this one is intermolecular hydrogen bond. This intermolecular hydrogen bond is formed between two or more different types molecule of same or different types. Here we use only water molecule, but here we use water molecule, and this one is alcohol. Now we'll discuss about intramolecular hydrogen bond. What is intramolecular hydrogen bond? When hydrogen bond is formed within one single molecule, then the hydrogen bond is intramolecular hydrogen bond. This hydrogen bond occurs when two functional groups of a molecule can form hydrogen bond with each other. Now, question number C. Melting point of orthonitrophenol is lower than the melting point of paranitrophenol. Where this one is orthonitrophenol. In orthonitrophenol, hydroxyl group and nitro groups are located at 1 and 2 position. These two groups can easily form intramolecular hydrogen bond. As a result, this molecule remains single, and that's why the melting point or boiling point of orthonitrophenol is lower. On the other hand, in paranitrophenol, The hydroxyl group and nitro groups are located 1 and 4 position. As a result, uh, intermolecular hydrogen bond intermolecular hydrogen bond forms between these two molecules. As a result, the molecules become closer and their boiling point is higher, and that's why the melting point of orthonitrophenol is lower than the melting point of paranitrophenol. Now, question number D. Arrange AH4, BH3 and C2D molecules according to their bond angle and explain the reason. What is the compound AH4? A, atomic number 6, that means A is carbon. A is carbon. B, atomic number 7, so B is nitrogen. C, atomic number 1, so C is hydrogen. And D, atomic number 8, so D is oxygen. So compounds are CH4, CH4, NH3 and water. Now we discuss about the shapes and angles of this compound. At first, CH4. Here the central atom is carbon 6. 1s2 electronic configuration, 2s2, 2px 1, 2py1, 2pz 0. In excited state, one electron shifted to 2pz orbital. C, 1s2, 2s1, 2px1, 2py1, 2pz1. Here, one s and 3p orbital mixed up one another and form 4 identical sp3 hybrid orbital. 1s2, 2sp3, 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 1, 1, 1, 1. Now each sp3 hybrid orbitals overlaps with the 1s1 orbital of hydrogen. 1s1, 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 1s1. Everyone is sigma bond. Now, what is the shape of this orbital? Here sp3 hybridization occurs. So, shape of is methane C, here hydrogen, 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 hydrogen. Shape tetrahedral. And bond angle 109.5 degree. 109.5 1.5 degree. Now we discuss about shapes and bond angle of ammonia. Ammonia, NH3. Central atom of ammonia is nitrogen. Electronic configuration of nitrogen is 1s2, 2s2, 2px1, 2py1, 2pz1. Now 1s and 3p orbital mixed up and form 4 identical sp3 hybrid orbital. 7, 1s2, 2sp3, 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 1, 1, 1. Here 2 electron present in s orbital, that's why here we use 2 electron. So this sp3 hybrid orbital occurred this 2 sp3 hybrid orbital contains one lone pair electron. 1s1 hydrogen, 1s1 hydrogen, 1s1. Bond formation occurs, and this one is sigma bond. This one is lone pair electron. So the shape of ammonia here 3 sigma bond occurs. This one is lone pair electron. So shape pyramidal. Shape pyramidal and bond angle. Bond angle 107 degree. Why bond angle is 107 degree? Because here lone pair electron is present according to Vosper theory. That means valence shell electron pair repulsion theory. LP repulsion is higher than BP repulsion, and BP repulsion. This is the arrangement of repulsion of lone pair and bond pair electron. Here lone pair bond pair repulsion present, that's why the bond angle turns into 107 degree from 109.5 degree. And now the shapes and bond angle of water molecule. Oxygen 8, 1s2, 2s2, 2px2, 2py1, 2pz1. 1s and 3p orbital mixed up and produce 4 identical sp3 hybrid orbital. 1s2, 2sp3, 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 2sp3. Here 2sp3 hybrid orbital contains lone pair electron. sp3 hybrid orbital containing one electron bonded with the 1s1 orbital of hydrogen, sigma bond. This one is also sigma bond. Here we see that 2 lone pair electron is present. For this reason, the shape of water molecule oxygen, two lone pair electron present. In this shape, two lone pair electron repulse one another. That means LP-LP repulsion present, and here also present LP-BP repulsion. So the shape is V shape, and due to lone pair repulsion and lone pair bond pair repulsion, the bond angle is 104.5 degree. So if we see these three shapes and bond angles, we can arrange them like this: CH4, NH3, and H2O. That is, bond angle is 109.5, 107, 104.5. This is their arrangement. Okay. Dear students, here given stamp 2. Here, this one is element ACMRX and electronic configuration of this element. Here, N-1 D6 NS2. Here given N equal to 4. So what is the element A? If N equal to 4, then N minus 1, that means 4 minus 1, that means 4 minus 1, that means 3D6 and 4S2. So electronic configuration of A is 1S2, 2S2, 2P6, 3S2, 3P6. So total electron of this element is 26. So this one is iron 26. So A is iron. Second one, N minus 1 S2, N minus 1 P5. That means 3S2, 3P5. So 1S2, 2S2, 2P6, 3S2, 3P5. Total electron is 17. Total electron 17. So C represents chlorine. Now this one is C. Now M. N minus 2S. N minus 2P4. Here N minus 2 means 2. That means 4 minus 2 equal to 2S2, 2P4. This one is M. So we write 1S2, and here total electron number is 8. So the element is oxygen. Now R, N minus 1, that means 4 minus 1, 3S2, N minus 1 P4, that means 3P4. This one is R, 1S2, 2S2, 2P6. So R represents here total electron 16, so R represents sulfur. And the last one, X, N minus 3, that means 4 minus 3 is 1, that means 1 is 1. So X represents hydrogen. So now we can easily say about the given compound AC2. What is AC2? AC2 is AC2. This one is A and this one is C, fluorine, chlorine. So this one is ferrous chloride, FeCl2. Now AC3, the compound is FeCl3, and X2M, X represents, where is X? H. X2M, where is M? M is oxygen. So this one is H2O, and X2R. X2, that means X2R equal to H2S, because R represents sulfur. So we can write AC2S, ferrous chloride, FeCl2. This one is FeCl3. X2M is H2O, X2R is H2S. Students, now question number C. Which of the compounds between ferrous chloride and ferric chloride is more covalent? To discuss about this question, at first we have to know Phasons Rule. What is Phasons Rule? For the polarization of ionic compounds, Phasons gave some rules. These rules are known as Phasons Rule. The greatest effect of polarization is produced in molecules having one, smaller size of cation, larger size of anion, high charge in cation or in anion, and the last one, cations with electrons in d or f orbital. In general, the greater the extent of polarization, the greater is the covalent character of the chemical bond. Now, if we see about this two compound FeCl2 and FeCl3, in FeCl2, Fe2 plus is cation, and in FeCl3, Fe3 plus is cation. In both case, chloride ion is anion, and the charge density of Fe3 plus is more than Fe2 plus. So the electron cloud is attracted more by Fe3 plus. According to Phasons rule, the more charge density, then polarization occurs more, and more covalent characteristics shown by that compound. So FeCl3 shows more covalent properties. As a result, we can say that FeCl3 is more covalent than FeCl2. If we discuss about their ionic properties or ionic bond, then we can say this one, that means FeCl2 is more ionic, and the melting point and boiling point of FeCl2 is higher than FeCl3, because ionic compound melting point and boiling point of ionic compound is higher than covalent compound. physical state of H2O and H2S. Oxygen and sulfur are of same group, and the hydrides of oxygen and hydrides of sulfur are H2O and H2S. Both have similar properties, but in room temperature H2O is a liquid but H2S is gas. Because H2O is polar compound but H2S is non-polar compound. Why H2O is polar compound? The electronegativity of oxygen is higher than hydrogen, so oxygen attracts the shared electron between hydrogen and oxygen towards itself. As a result, oxygen forms partial negative and hydrogen forms partial positive charge. In this case, partial positive hydrogen ion and partial positive negative ion forms intermolecular hydrogen bond. Intermolecular hydrogen bond, and these molecules becomes closer. As a result, the state of water molecule is liquid. Now, in case of H2S, H2S is non-polar compound. Why H2S is non-polar compound? Because the electronegativity difference between hydrogen and sulfur is very low. As a result, only van der Waals attraction force is present in H2S compound. H2S becomes gas in nature.